Hello, everybody, and welcome to episode 69 of Ask the CEO with Abraham Gottheil. Today, I'd like to introduce a very special guest. He's the Chief Technical Officer and a founding member of Aeris. He has over 35 years experience in the semiconductor, computer, and telecommunications industries, including product development, architecture design, and technical management. Prior to joining Aeris, he held senior engineering and management positions at Analog Devices, Cypress Semiconductor, CAD National, and ESS Technology. He presented papers and participated on panel sessions at conferences on machine-to-machine networks, Internet of Things applications, and cellular technologies for machine-to-machine and IoT. He serves as chairman of the IoT M2M Council, International Forum on ANSI 41 Standards Technology, and the Global M2M Realization Forum, and is on the board of the Mobility Development Group. It is my pleasure to welcome Syed Zaeem Hosain. Welcome, Z.
Thank you very much. Pleasure to be here.
Pleasure having you. Z, I'm so excited to be speaking to you today, and just excited about the advancements that your company, Aeris, has been making in the industry. At the rapid pace at which technology is progressing, it's estimated that there will be 50 to 100 billion connected devices by the year 2020, with many of them being in motion. What are some of the challenges that you've encountered with mobile IoT devices?
That's a very good question. I think that there are a remarkable number of challenges that you can encounter. When you deploy a mobile application, you have to think in terms of the fact that the application may be a mission-critical application that requires connectivity under all kinds of interesting and strange conditions, particularly when you may be out in a remote area. We focus primarily on applications that are deployed for the automotive industry, fleet tracking industry, as well as the devices that are not necessarily physically mobile. We categorize them in two different ways. You have the mobile applications that move around, and then you have the fixed applications that will stay in one place. In the mobile applications, coverage is usually the most critical problem. You can end up with these devices being in locations that simply do not have the ability to transmit data. You can end up with situations where a mission-critical data needs to be sent, and yet the system is not yet capable of receiving data at the speeds that might be required for certain applications. So all of that, managing all of that, making sure that the devices have coverage where they need to be, they can transmit where they need to transmit, etc., is something very important. And so we manage devices on behalf of our customers to make sure that these devices work under conditions that you wouldn't normally encounter with humans using a cellular system, which is what we focus on.
Great. And tell us a little bit about Aeris and the different ways with which you help businesses overcome those challenges with the IoT mobile devices.
Certainly. If you don't mind me giving you a little bit of a history, since we have been around for a number of years, Aeris is one of I will call it one of the pioneering companies in the area of M2M and IoT. Frankly, we came into existence before those two phrases even existed, machine-to-machine and the Internet of Things. We were helping customers with a particular kind of data transmission using cellular networks before digital data became commonly available for use for these kinds of purposes. People were using various kinds of slower speed modems, relying on servers being present, and it was very difficult to scale the kinds of applications that you might need to do for these kinds of large-scale deployments, ending up with billions of devices, as you pointed out. So when we got started, we had the capability of sending a small amount of data, which was ideal for a certain class of industrial applications, if you will. Machine-to-machine applications in the alarm and security industry, applications for recording vehicle location, recording fleet locations, like recording information about the content of a trailer, for example. Our two initial large customers were in those areas, as a matter of fact. When you start to scale, and what I mean by scale is deploying large numbers of units, you have to provide reliable connectivity, reliable access to the devices out in the field, and make sure the data indeed is being received at a level of support and integrity for the data that is required for these kinds of applications. People can be remarkably tolerant of cellular imperfections. If the call doesn't work in a particular location, human beings can make the decision to try the call later. When you have a machine application, it's kind of tough. The machine has to know, oops, I'm not getting through. I need to make something different happen. I need to try again later on. And then I need to have an intelligent retry mechanism. I shouldn't just keep hammering the network in an effort to try and get through. So all of those things take a significant amount of effort. What we try to do is make sure that our networks are as reliable as possible. The networks stay up as much as possible for the coverage maps that we have on a global basis, not just within the United States, pretty much around the world at this point. And make sure that the capabilities for receiving that data from the device, transmitting it through the network, having it arrive at the server systems that need to receive that data is reliably managed and maintained. And if there is a problem in the network somewhere, which there always is, there's some difficulty out in the field somewhere, to notify our customers and say, hey, we're having a problem in this particular market. It's not your devices, it's not your application. The network might need to be managed and corrected. The deficiencies or whatever problem might be occurring at that spot need to be fixed. So we rely on the fact that we can provide a managed capability for the large numbers of devices that people deploy. One other point I will mention is that over the years, we have learned that companies are not deploying 5, 10, 15 devices. They're deploying thousands, tens of thousands, millions of devices. And that's how we're going to get to those billions of devices out there. So you have to provide reliable service, and the availability of the service has to be managed. The devices have to be managed. You have to understand what devices may or may not be working, and whether it's a device flaw out in the field or there's a network issue. One of the first things that we have learned, when you have millions of devices with the size of the company we are, is you cannot expect every device or every owner of a device to call in on an individual failure. You're going to get calls related to large numbers of devices. So operating at scale is something that we pride ourselves on, and making sure that the automated information necessary for customers to understand what might be happening to their devices in a region, and maybe it's in a country somewhere that has some difficulty with getting the data beyond the boundaries of that country, etc. So a large numbers of things have to come in play for an application to be successful. Remarkably enough, it takes time to get it all going, but once it's running, people can expand and deploy the large numbers of devices that they need to make IoT in general and their solutions in general work for them.
Great. And, let's dig a little deeper into this. So
Sure.
Let's take a real world scenario, something that everybody's talking about, which is autonomous vehicles, right?
Right.
So, one can only imagine the different moving parts with regards to the communications that needs to take place in order for it to work successfully.
Absolutely. Yeah, that's a very good point. And in fact, let me start by giving you a little bit of information that people might not be aware of. There are different degrees of autonomous, right? You can have cars that are called level 1 category, which simply don't have any connectivity at all, which is typically the case for the majority of cars out there today, all the way up through defined levels of operation, where typical cars that are providing connected car applications today are called level 3, category 3 applications, all the way up to level 5, which is where you don't even have a steering wheel, and the assumption is that the vehicle is going to do all the right things to get the passengers from point A to point B reliably, securely, and without having any kind of a problem. The amount of effort it takes to go from a level 1 to a level 3 to a level 5 car is actually pretty enormous. The connectivity, surprisingly enough, will not be able to keep up with the level 5 requirements, meaning it will be a combination of local processing, very high-speed local processing, because you have to account for the vagaries of traffic conditions, people stepping in your way, other cars, road conditions that dynamically change. You might have weather conditions and patterns that dynamically change. So level 5 cars are a ways in the future. And I will not use the word skeptic. I will use the word make sure you wait long enough, because it's going to take 5, 10, 15 years to get to a full level 5 car. Although the plans and the expectations for people and the manufacturers are certainly there. Level 3 cars, level 4 cars are possible today. They're viable today, where you can expect the car to do the majority of its functions properly for you. You can expect the fleet, perhaps in constrained environments like a highway condition, from one end of a delivery chain to another end of a delivery point, to work correctly for you. It is the unexpected events that will require significant processing capability right within the vehicle. And then the wireless transports, typically the 5G cellular transports that are coming along, will aid that. They will not be the immediate real-time capabilities that a vehicle autonomous, even a level 4 car might need. There will certainly be the kinds of data updates that you will require to make sure you have enough real-time information for changes that might be occurring. You might have a road condition down the road ways down the road on the highway, which is dynamic. Somebody has put up a barrier because they're trying to do some road work. Well, you need to have that information available so that the car can make an appropriately effective decision or provide the information to the driver to perhaps either take control or make sure that that condition is dealt with in some intelligent way. That's where some of the newer cellular technologies such as 5G, I think, are going to play a major role. Map updates, dynamic information updates, things that can provide sufficient warning sometime down the road so that the cars can take advantage of that information that is provided to them. Things that happen real close by, right there, have to be processed in the car. Physics gets in the way.
I'm so glad you're saying this, because this really dispels the myth of 5G being the be-all, end-all for things like autonomous vehicles.
I think it is a requirement to be able to do reasonably fast updates with low latency for the kinds of stuff that might be happening in your surroundings a little bit further down the road, but it is not going to be useful for communications and control in real time, meaning there's no way you're going to remotely control a car and expect it to be able to manage the situations and states that it might find itself in a local environment. You have to process a lot of that information locally, whether it's using information from radar sensors, from LiDAR sensors, or even some of the video cameras that are being deployed today in autonomous vehicles.
Right. And, I'm thinking also that the term connected car says a lot, because if you think about it, when a human drives a vehicle, it's not a human driving and then the rest of the world is just gone, right? We are constantly interacting with the world. We're hopefully looking out the window and paying attention where we're going, but we're monitoring the entire environment around us. And that's what an autonomous vehicle needs to be doing. It needs to be connected to smart infrastructure. It needs to know the traffic lights. It needs to know whether someone stepped on the pavement and things like that, in order to be able to make the same kinds of decisions that humans make when driving cars.
That's exactly right. There are new technologies in the works for short-range radio transmissions. They're lumped under a generic term called V2X, vehicle to infrastructure, vehicle to other vehicles, etc., where you can receive information, very short-range information, for what will impact the connected vehicle, a general-purpose connected vehicle. So, for example, the lights, being able to monitor and change and understand when the light is about to turn red, vehicles can come to an appropriate decision point as to when they should stop, when they should start braking, etc. The problems that can occur in that arena, I am concerned about not the fact that these technologies are possible. They're certainly viable. Processing technologies have become really good, and large-scale processing within the vehicle itself is going to require these kinds of capabilities for autonomous vehicles to be successful in being deployed. But there will be a transition period where a significant number of cars will be autonomous and a large number of cars will not. And managing what happens on the streets as we know it today is going to take a little bit of effort. Now, whether or not we end up using constrained environments, meaning that certain kinds of regions within a city may be only autonomous, or allow only autonomous vehicles of a certain level to enter those areas, is still something that I think regulators still haven't figured out what needs to be done in the future. That's going to drive some of, no pun intended there, that's going to drive some of the capabilities that people will need to take into account when they're driving connected vehicles. The vehicle to infrastructure element also has a cost barrier that we need to be aware of. As these requirements evolve, being able to receive information from smart lights, the road conditions, maybe smart road sensors, etc., communities, municipalities, cities, all of these states have to put all of that stuff into play and make those changes happen for cars to be able to use that data. Well, that's a tremendously, incredibly high cost barrier. That's going to take some time to get there.
Yeah, for sure. So let's switch topics, talk about agriculture a little bit.
Sure.
According to the USDA, agriculture accounts for about 80% of our nation's consumable water. And in some Western states, even up to 90%, which means that we're not drinking this water. And in addition, right, we're dealing with things like a growing population, climate change, which will further our need for additional drinking water. What can we do about this?
That's a darn good question, and frankly, a very tough one. The issues of water quality is going to be something that is, and availability, frankly, of good, clean water is one of the major issues facing the world, not just the United States. Globally, there are initiatives to find clean water for people. There are initiatives for making sure that the quality of the water is appropriate to make sure that you do not have any medical or other kinds of problems as a result of not having the right quality of water, and then the availability of sufficient water. The things that we need to take into account have to do with efficient management of the water system. We have applications. Now, when I say we have applications, really our customers who deploy these applications on behalf of the specific IoT function that they're trying to achieve. We have companies who are deploying these kinds of water management applications so you can effectively avoid losses, find the leaks, measure the quantity and the quality of the water that is being given out to various cities. We have companies who have taken their products and deployed them in a number of major cities inside the United States, where the water meters can now report back in a very efficient way how much water is being used, that none is being wasted, and in particular, leak detection. If a water loss occurs in one region, you want to make sure you find that as quickly as you can and take care of the problem. In the foreign countries, for example, we have some initiatives with some companies in Africa where the availability of water pumps in villages is a very big deal. The fact that the water pumps sometimes break, even the hand pumps sometimes break, you need to monitor them. You need to make sure you can get to them and repair them as quickly as possible. And in particular, water desalination projects that are being deployed that are self-sufficiently managed, meaning there's nobody watching the operation of these systems, can report back when there isn't indeed a problem, so you can go out and take care of these devices out in the field, these big, large desalination project systems, if you will, out in the field. Water is going to be a big deal. As was said by a UN Secretary General years ago, it's the reason that wars will be fought in the future if you're not careful. It's going to be one of the problems that mankind has to deal with. Availability, good clean water, making sure it works right. Our customers are helping in that area. Another project that we've been working on is monitoring in the agricultural field in the United States. Is one of our customers monitors the delivery of water to the field. If you've ever been on a plane flying above the Midwest, you'll see these giant circles where water is delivered using
crop circles.
Crop circles, exactly. And quite frequently, these machines will stop working, or the water delivery will stop because something is broken, the motor might not be working well, etc. Before IoT applications came along, the traditional way of determining this was somebody running around in a truck, walking to all the fields and saying, yep, everything's okay. The new method is there is a monitoring device in the center of the system that makes sure that the motor is working properly, the water is being delivered, it can be remotely turned on and off, and enabled to provide the right amount of water for the crop that's being grown, et cetera, et cetera. This is leading to efficiency of the water management for agricultural purposes that I think is going to be very important in the future.
You know, one of the things that I notice when I go out early in the morning, I go running, I notice that everybody's got sprinkler systems. And it could be raining outside, but those sprinkler systems are going. Now, one can only imagine in the farms that use up 90% of the water. What are we doing with regards to irrigation?
Well, that's a good point. I think the home residential systems have not yet advanced to the point where they perhaps need to, where if it's raining outside and you don't need the water, they should shut off. In the case of the agricultural systems, particularly the large-scale deployments, they do have these systems where they can remotely control that. And that's exactly the purpose behind these deployments, is when it's raining, they can have these systems automatically shut off or have it remotely controlled. So a particular site or a particular engineer is the wrong word, but a farmer who decides that there's sufficient water being delivered can shut it off and doesn't have to worry about it. And in particular, they have sensors nowadays that measures the water that's being delivered by other sources such as rainfall.
That is a very innovative solution where it measures the actual level of water in the field. So if there is water on the ground for whatever reason, then yeah, don't turn the sprinklers on.
Exactly right. And we had a customer who deployed many of these systems at wineries, which is another place where water gets used quite a bit. But more importantly, you have to be careful about the kind of spores that might damage the grapes. So they have these very sophisticated sensors that not only measure the water content of the soil, but also make measurements about a particular kind of spore in the air or the amount of sunlight that the grapes are getting, etc., and correct for that, because you want to make sure that the ideal growing conditions exist for the grapes.
What I find fascinating about this technology is that we take our food and water supply for granted. We don't even know what goes into it in order to make sure that we have, like you mentioned, grapes or wine or food. I'm talking about another topic that's similar to this, the cold chain. Many people are used to, when you want to drink milk, you walk over to your refrigerator, you open the door, you pull out the milk carton. Oh, the milk's empty. No problem. Let's just go to the grocery store and buy another bottle of milk. But do you even realize what it takes to get those perishables from the point of origin to your refrigerator?
Mm-hmm. That's exactly right. Let me use a more interesting example than the milk analogy in this particular case. Cold chain is so important and critical in medical delivery, you'd be amazed. There are certain medications, vaccines in particular, that have a very, very narrow temperature range of operation that they can be stored and used for. In particular, there was a study done years ago which said that vaccines being delivered in Africa, sub-Saharan Africa, it wasn't clear at all whether the quality of the vaccine had been maintained, because you have to ensure that the vaccine, the live vaccines for many diseases, stays within a certain range, and that range is incredibly narrow, 2 degrees centigrade to about 8 degrees centigrade. If it goes below 2 degrees, the bacteria, the virus, that they're trying to inject in the vaccine is dead, and if it's above 8 degrees, it's dead. You have to make sure it's maintained in a certain range from the point of manufacture to the point where it's injected into a child. That cold chain requirement led countries to estimate that perhaps 50 to 90% of the vaccines they were delivering to children in some of those countries simply didn't work because it had been subjected to temperature ranges beyond those boundaries. So the act of monitoring that kind of a medical delivery system where the vaccine needs to stay within a certain range, literally to the point where it's injected into a child, it doesn't have too many excursions beyond those boundaries, to make the vaccine viable, is something that's incredibly important. Systems are being put in place for doing that. And when you look at other perishables, such as milk, as you mentioned, and other perishables that need to stay below a certain temperature, we do have certain excursions that can take place for milk, which the vaccine would not tolerate. So depending on the tolerance level for the particular perishable that you're trying to keep track of, you set up systems to do that. Most delivery systems in the United States today, refrigerated trucks, etc., are in the right range, but you have to make sure that you maintain that, and then you report when they do leave that particular range. This has been a traditional problem in the past, and again, new systems are being put in place. We're working with a certain number of fleet companies that have deployed these kinds of sensors on the refrigerated trucks, so you can monitor the temperature of the truck and make sure that the product that they're delivering is indeed still viable and working properly, like in the case of milk, from the dairy farmer to the place where it's packaged up.
Wow. And to think that with this technology, with IoT technology, you're saving lives of children around the world.
I feel good about that. We have a gentleman who works in our company who is responsible for all of those kinds of social good applications that we're responsible for, if you will, for our customers to support them for these kinds of applications. It's pretty cool stuff.
Yeah, indeed. And, that's one of the things that I love about working in this industry, and that is, besides the business applications, besides, all the conveniences and the profits and all that, we're literally helping save lives, and that's a real special thing.
It is indeed.
Great. So let's talk about another industry that's heavily reliant on IoT technology, and that's the shipping industry, which according to the International Chamber of Shipping, the ICS, they're about 90% of the global trade. With millions of products traveling across our seas on a daily basis, how do our global shipping partners keep track of all this?
That's a good question. And a tough one. Again, another tough question. Thank you. One of the things that's interesting about the shipping industry is that it's easier to keep track, if you will, of products once they leave the ships and they go onto the railroad system or the trucking delivery system, because you have access to a data transport technology, the cellular system in most countries, where you can send and receive data from that product. In the shipping industry, in the past, it's traditionally been relied on that you put the item on the truck, the ship, that it went onto the ship, and then when it arrives at the destination port, that's when you record that it arrived and you track it. And obviously that is good. It's not a perfect system because you lose track of the product during the time when it's at sea. And that is changing. There are new satellite transport systems that are coming into play. In particular, in the next 5 or 10 years, you will see these low Earth orbit satellite systems designed to receive data from devices that are out in the middle of nowhere on the ocean. And so shipping containers are being changed to accommodate these kinds of applications where they will transport asset information, what's in the content of what's in the container, what asset is in there. And in particular, if it's a refrigerated container or something like that, which is rare in the shipping industry, but it does happen, then you can transport whether or not it has seen the temperature excursions in a cold chain scenario. Those transports are just coming into play. They've been traditionally too expensive, the systems that are out there today, but you're going to start seeing a large number of new satellite data systems designed specifically for IoT and M2M applications to track product at sea. And of course, you have the traditional ways of doing RFID systems and scanning systems that allow you to understand where the asset might be. But those are still very manual. It's the automation aspect of it that is incredibly important. We're working with some companies today who are solving the shipping problem with boxes, small boxes of delivery today, where you could essentially deploy a little unit inside the box. It lasts for 2 weeks and it monitors where the device might be in the shipping chain put on land. And that in the future will be accommodated at sea as well.
Yeah, and one of the things that comes to mind is ports are very busy places, and that's when things get lost, right? They, the big crates that are on the ships, well, they pretty much go from point A to point B, but then when it gets onto the port, they open these crates and boxes are all over the place, and that's when solutions like this would come in handy.
Absolutely true. There is another company that we are not working with them, but I can refer to what they're up to. They're in fact putting together some port management systems where they will have these smart containers that transmit data using the same kind of technology transfers that are being used for the vehicle to infrastructure and vehicle to vehicle data transports in the autonomous vehicle area. They want to manage ports, the containers within the ports. Typically you stack these containers 5, 10 containers high, and then you need to be able to get the data reliably. Wi-Fi doesn't work in these ports because of the metal that's in use in these containers, and also the tall walls that can cause you a problem. So they're looking at alternative ways of monitoring what's available, where the containers are within the port, how it's being moved from one port to the other, and how are the vehicles that transport and move the product within the port and open it up and then take things out are all managed in a comprehensive system. That's going to be a very powerful, I think, a very powerful application for keeping track of assets so you don't lose them.
Yeah, indeed. So, Z, this has been a really fascinating conversation about the different kinds of innovative technologies that you work with. What do you think's next for the industry?
There are concerns. And one of the biggest concerns that you'll encounter in these kinds of applications is that because they are connected, they're subject to hacking. They're subject to security problems that we have experienced on the internet or in the financial industry, for example, with people breaking in and taking advantage of the information. We have experienced security breaches in the IoT industry, which have caused people to think very hard about security implementations. particularly at scale. And you mentioned right in the beginning of this chat about the billions of devices that might be out there. Well, imagine what could happen if a large number of those devices, whether it's 50 billion or 100 billion, some large fraction of those devices were taken over and used in a destructive way, okay, to hack the internet or to cause problems for customers who are not related, who are not using those kinds of devices. So to me, security, particularly security at scale, is a concern. It is the kind of thing that could hold us back from achieving those kinds of billions of device solutions that everyone wants to believe will happen. It is a fantastic growth area, but we have to take security into account. And that's something that I'm a little bit of a soapbox at this point, but I think it's incredibly important. The fascinating part about this industry is that IoT and M2M can have an impact on a variety of different ways, of things that you wouldn't even think about. It isn't just your smart thermometer at home or thermostat at home. It isn't just your smart home. It isn't just the connected vehicles that consumers see. It's the industrial applications, the agricultural applications where you can gain efficiency from a product delivery perspective or water quality maintenance perspective or monitoring the perishables that could occur, that could get damaged by any kind of a fault that occurs in the delivery system. That's where I think the power of M2M and IoT comes into play. And as the old phrase goes, you ain't seen nothing yet. It's going to be amazing in the near future. The kinds of ways that we will see this all help us without being a barrier in any way, shape, or form.
Great. So, Z, we have a question from the audience. And the question is from Sudha Jamthe. She is the author of the book 2030, The Driverless World. And Sudha asks, AI today is specialized to do one task each, and all models are trained offline and run as inference models in a live vehicle or an IoT module. Given this reality, what is needed for autonomous trucks to act in real time based on their diagnostic data to make decisions whether to refuel themselves or go for service to someplace without human intervention?
That's another tough problem, right? It's very easy for machines to follow pre-programmed software, pre-programmed paths, make sure that they can do exactly what they were designed to do. It's a whole area of machine learning where things need to adapt. The programs and processes and systems need to adapt to what might happen. That's an area of where I think there is a tremendous amount of research being done on the kinds of things that a car or a fleet truck would need to take into account to be able to do exactly that. When is the gas going to run out? When is the maintenance schedule going to require me to go in there and have some work taken care of? This is all data processing that is happening today. The AI techniques and machine learning techniques that are in development. This is not something that I can tell you is absolutely available today, but it's in development right now. For the near future, we'll make it all happen. Cars have to get smart. Fleets have to get smart. Trucks have to get smart. But that's why I believe it won't happen tomorrow or 5 years from now. It may take a little bit longer. It's going to need to be done. The data processing requirements, being able to store that data, analyze that data, make predictive analytics become a reality rather than the kinds of experiments that we're doing today, it's just going to take some more time, more processor power inside the vehicles, etc. But it's happening.
Great. Z, who would be an ideal client for your company?
Any company that needs to get remote access to systems and devices out in the field, gather data, bring that data back, analyze the data for the very simple purpose, which is that they're trying to make efficiency gains happen. They're trying to increase their revenue or cut costs, make it work better for them. Any company, any enterprise. We do not sell directly to consumers because we're operating at a large scale. Companies who need to have data remotely gathered or devices controlled out in the field, we can manage and help them. That's what we do.
Fantastic. And how do people connect with you?
Please come to our website. Take a look at what we're up to. It's www.aeris.com, and you can see the kinds of devices and applications that our customers have developed already. And come talk to us, because we will frequently get surprised by new applications that people believe is essential to their business that we just haven't seen in the past yet, and we can help them. Be aware that it takes time to get a product designed, developed, and deployed out in the field, and then to start manufacturing at scale. But we can help them. And we've had customers who come in and have a ready application where they can find off-the-shelf hardware and essentially get going immediately. And then we have customers for whom cost of deployment for a large number of devices means that they have to build a custom product, and we can help them get there as well. We don't do the hardware ourselves, but we have relationships and partnerships where the customers we get can find the appropriate resources to get their applications deployed. Come talk to us. You'd be surprised at the kinds of applications that we do get. Some are beyond the scope of what we can do, but then we can refer you to other people. And some are beyond the scope of what technology today can provide, but certainly it's interesting to see those kinds of interesting and challenging applications that we may be able to help out with.
Yeah, exactly. And I'm going to post your website to the show notes so people can just look it right up and click on there and get right to you.
Thank you very much.
Great. Z, do you have any parting words of wisdom that you'd like to share with the audience?
This is an enormous adventure for all of us. I'm a founder of Aeris. I've been here more than 20 years, 23 years at this point. And I can tell you, it's still fun to get up in the morning and coming in and see some of the things that are being done by our customers. It's the kind of world that I think will revolutionize what mankind, in a sense, will be all about. We've seen revolutions in the past. I think the ability for technology and data and information to help in a variety of different markets, whether it's medical or consumer applications, industrial applications, this is just a fascinating area to be in. It's a wonderful place to be.
Great. Z, thank you so much for sharing your time and your wisdom. I really enjoyed having you on the show.
Thank you very much. I appreciate the time as well.